In today's video, we're going to be looking at triangle congruence conditions, which can also be called postulates. So understand the definition of congruence and understand the 5 conditions for triangle congruence. That's your learning target today. So you have 5 conditions or 5 postulates that help you determine if 2 triangles are congruent or not. So to go over some vocabulary, let me go ahead and start highlighting these things. So congruent is a huge word, and that is the symbol for congruent. It is just an equal sign with a squiggly line on top of it, okay? So congruent is when 2 shapes have a sequence of rigid transformations that carries one onto the other. The corresponding angles and sides of congruent polygons have equal measures, and congruent shapes are similar and have a scale factor of 1. Okay, so what it means by if there's a sequence of rigid transformations, do you remember back in, I think, Math 1A, where we learned about reflection, rotation, translation? Those are rigid transformations. So for instance, if I have a triangle here, and a triangle here, they don't look very congruent, but can this triangle go through a series of rigid transformations that carries it to over here? And it looks like I could probably rotate it, translate it, and it would land right on top of the other triangle, making them congruent shapes. Then there's something called similar, which we actually won't get into in Math 1B. Similar just has one squiggly line. You're going to get into similar triangles in Math 2. But 2 shapes are similar if there is also a sequence of rigid motions followed by a dilation that carries one onto the other. The corresponding angles of similar polygons are congruent. The corresponding sides are proportional. Okay, so again, this is more like Math 2. And then correspond, you're going to hear me say corresponding a lot. So the points, sides, edges, or angles in 2 or more figures that are images of each other with respect to a sequence of transformations correspond. If 2 figures are congruent, their corresponding parts are congruent to each other. So let's see if I can make up a quick example. Again, sorry, my triangles are kind of bad. If I say A, B, C, D, if I say this is 60, and again, I'm making these up. Let's make, I don't know, 80, what would that make this, 30? 60, 70, 80, 90, no. 20. Okay, no. Oh God, I need to cut here. Here. Let's do this. Okay. So let me try to make 2 examples. If I have one triangle here, that's a right triangle, sorry, and then another triangle here, and I have A, B, C, D, E, F, and I say this is 60 degrees, 60 degrees, I would say that angle A corresponds with angle D, and angle B corresponds with angle E because they're both 60-degree angles, and angle C corresponds with angle F because they're the same angles. So then that's why A and D correspond with each other. I can also say the sides correspond with each other. Side AB corresponds with DE. And how could we write that they're congruent? AB, oops, is congruent to line DE. Okay, AB, now let's say I call this 5 and 5 there. Now I've proven that they are congruent to each other, right? Because they're both equal to 5. I can also say angle A is congruent to angle D. And lastly, I can say triangle ABC is congruent to triangle DEF. Okay, so these are very important sentences here we're making that you're going to need to be successful in this chapter. triangle ABC is congruent to triangle DEF. Angle A is congruent to angle D. Side AB is congruent to side DE. Okay, and so understanding, and also everything goes in order, right? So if I have AB, it better correspond with DE, and it does. AB is congruent to DE. Okay, so order matters. If I say, what corresponds with BC? Order matters. So BC would correspond with EF, and BC is congruent to EF. Okay, so let's go ahead and move on. Real quick, which of these polygons are congruent? So we can kind of begin to understand what does congruent mean. You can go ahead and pause this video, but I'll go ahead and start. E, what does E correspond with? I've got this, or not correspond, sorry, congruent with. It looks like E is congruent with H. And what are some transformations that could have been done? It looks like it was reflected, right, across a vertical line. So it would look like this. And then it was translated to end up right here. So E and H are congruent. J does not have anything congruent to it. A and I, they look similar. In fact, they probably are similar, but they're definitely not congruent. This one is much bigger than this one. There was a dilation that occurred, which occurs with similar triangles. Okay, I know B and D look alike, but I believe if you were to rotate and translate, it actually wouldn't be congruent to each other. Well, let's see which three are. So when E and H are congruent, G and L, where is G? G and L, yep, maybe it was rotated and translated. It doesn't look like it was reflected. And then F and K. Oh yeah, F and K. It looks like it was reflected, rotated, and translated. It looks like it had all three transformations. Moving on. So now we're going to start looking into the 5 postulates or conditions that state that 2 triangles are congruent. And the first one is SSS. That's what we're going to refer to as side, side, side. If 2 triangles have the same 3 side lengths, then the 2 triangles are congruent by SSS. Okay, and it's good to get in the habit of putting the symbol here because eventually you will get to similar triangles. And there are some postulates that share, like maybe you have SSS for similar triangles. And so you want to get in the habit of putting that congruency symbol. Also, in case you didn't know, these tick marks tell me which sides are congruent. So this one with 1 line is congruent to this one. Okay, those 2 correspond. This one with 2 lines is congruent to these 2 lines. These 3 lines tells you that this side is congruent to the side with the 3 lines. Okay, so here's an example of 2 triangles being congruent because each of their side lengths are equal to each other. Okay, so let's see if these 2 triangles are congruent, and if so, let's write a congruence statement. A congruence statement is really important. So I'm going to check if these are congruent. There's 1 side, 2nd side, 3rd side. It looks like I've got a side, side, side. So these are congruent. And I'm going to go ahead and say a triangle ABC is congruent to triangle, let's see, if AB goes down the line with 2, I'm going to go, it looks like here, X to Y, because it goes down the side with 2 lines. And then from B, I went to C. From Y, I'm going to Z. So that is a congruence statement. And the reason is by SSS. Very important. Okay, let's go ahead and try this one. By the way, if 2 sides, if they share a side, if 2 triangles share a side like this, then obviously that 3rd side's congruent. So I'm going to add 3 lines to show that the 3rd side of both triangles are congruent. And if you need to separate them so you can see it better, do it, right? There's W, ZY. Okay, so these are congruent by side, side, side. I have one side, two side, three sides, congruent to 1, 2, 3. So I'm gonna go ahead and write my congruence statement. I'm gonna say triangle, doesn't matter, let's do WZY. I went W down to the Z, so I went across the two lines. So I'm gonna start also at W, go down where the two lines are. So WX, and then from Z I went to Y. So from X, I'm gonna go to Y, right? And how do we know this? By side, side, side. By the way, there's no particular order you have to start with. So you could have said, maybe you went BCA. That's fine. But then you have to find the corresponding parts on the other triangle. If I start with B and I go to C, start with B and I went to C, I went across the line with one tick mark in it. So it looks like I'm going to start here and go across to Z. So it is congruent to triangle Y, Z, and then from C I went to A, so from Z I need to go to X. Okay, so it doesn't necessarily matter what your order is of the first triangle as long as it's congruent to the corresponding parts of it. So that is side, side, side. Let's try the next one, and I do have the answers here. I don't know how to do the symbol triangle in slides, I'm sorry, so that's why I write it out, but make sure this is how you're actually doing it on your paper. Do not actually write out triangle, okay? So next one, side, side, side. Now we've got side, angle, side. So if two triangles have the same two sides with a congruent angle in between those two sides, then the two triangles are congruent by SAS. And you'll often hear me say SAS, okay? So if you have two sides that are congruent with an angle in between that is congruent, then those two triangles are congruent by SAS. Okay, and just like the tick marks on the side of a triangle show that they're congruent, you can do the same with angles. So if that is 1 and 1, sometimes you'll see people do 2 lines. Or sometimes what you might see instead is, like I know the textbook does tick marks in it. So they'll do 1 line, but they'll do 3 tick marks. Okay, same concept. So that is SAS. So let's go ahead and determine if these triangles are congruent, and if triangle ABC is congruent to, I went from A to B. Looks like there's no tick mark, so I'm going to find my side with a tick mark. I'm not going to go Y to X. That's what I was thinking. But see how from A to B, you're going to the side with 1 tick mark? If I go from Y to X, I'm going to the side with 2 tick marks. So actually, I need to go the other way. It would be Y to Z. That's wrong too. Okay. So if I started from A to B and I'm going this way, it looks like I'm going from the 2 tick mark across nothing to the 1 tick mark. So I'm going to go from the 2 tick mark across nothing to where the 1 tick mark here is. So I'm going to go triangle X to Y, and then from B to C across 1 tick mark with 1 angle tick. So I'm going to go across here to Z. So triangle ABC is congruent to triangle XYZ by side, angle, side, postulate. Okay, let's figure this one out. We've got an angle, okay. We've got a side, yeah. What else do we need? This is by SAS, right? Oh no. Are we given another side? We're given an angle, a side, and no other side. So this one is actually not necessarily, oh gosh, I'm not an English teacher, okay? Congruent. That means we don't know. It could be, maybe they are, but we are not given enough information to see if these are congruent or not. And actually, I already know that my PowerPoint has a mistake. It is going to say that these are congruent. I apologize. They are not, at least not by SAS. I was thinking something else when I made this. Do any of you know how this could be congruent? Possibly. To give you a little hint, angle, angle, side, which I believe we are doing on the next slide. So here we're doing angle, side, angle. So far you know SSS, you know SAS. Now we're doing angle, side, angle, and angle, angle, side. There's only one difference between these two, okay? For angle, side, angle, you have an angle, a side, and an angle. This side is between the two angles. At angle, angle, side, the side is not between those two angles. It's next to. And so let me change my colors. Here we have angle, angle, side, angle, angle, side, angle. These are congruent by angle, side, angle. Here we have an angle, angle, side, right? Because two sides that share, they're congruent to each other. And then I have an angle, angle, side. So that's the two differences. One has the side in between the two angles. That's why it's called angle, side, angle, because it's squished in between two angles. And then we have angle, angle, side. When the side is not between the two angles, that's when you would use angle, angle, side. Let's try some new examples. Over here, determine if the two triangles are congruent, and if so, identify the condition and write a congruence statement. So let's see. Go ahead and try these on your own first. It looks like I've got an angle, angle, side. Do I also have an angle, angle, side? I do. However, they are not in the correct spots. Do we see how this tick mark is next to the one tick marked angle? This tick mark is next to the double tick marked angle. And so these two are not necessarily congruent. Looking over here, we have a angle, angle, side. Here we have an angle, and a side. So these two triangles are congruent. Let's write a statement. I'm just going to do ABC is congruent to A down to B. It looks like, correct me if I'm wrong, F, D, E. Let's see if I'm right. Let me look at this again. A to B, F to D, B to C, D to E. Yeah, that's right. And by what? Here we did angle, angle, side. Let's look at this one. What do we have here? We have an angle, a side, and an angle, side, and an angle. So those two triangles are congruent. I'll go ahead and do ABC. Congruent to triangle. Let's see if I go to A. A has no tick mark, B has one. So I'm going to start at D, which has no tick mark, and go to the one with one. It looks like it's E. And then from B, I went to C, one tick to two tick marks. So from E to F, one tick mark to two tick marks. And this time it's not angle, angle, side, it's by angle, side, angle. Okay, do you see the difference between angle, angle, side and angle, side, angle? Now I believe there is, of course, another mistake. That is incorrect, right? We did not see that these two are not in the correct spots. Bad, bad, bad. So these are not necessarily congruent. Okay, moving on. We have the last one, everybody, hypotenuse leg. This is a simple one, although it can look tricky sometimes. If the hypotenuse and leg of one of the triangles is congruent to the hypotenuse and the leg of the other triangle, then the two triangles are congruent by HL. So you're going to see a 90-degree angle, and you're going to see that the hypotenuse and any other of the two legs are congruent. So when we're working with a 90-degree angle, this longest side across from the 90-degree angle is the hypotenuse. Oops. And then here's leg one and here's leg two. So as long as you have hypotenuses that are how do you say more than one hypotenuse? If you have them that are congruent to each other and one of your other legs is congruent, then they're congruent by HL. So looking at this, we have the hypotenuse, one other leg, and it is a 90-degree angle. So this triangle ABC is congruent to triangle XYZ, it looks like, okay, by hypotenuse leg. Let's look at this one. I didn't put any letters here, but this is also congruent by hypotenuse leg. The hypotenuse of this triangle is congruent to the hypotenuse of the other triangle on top because they share a side, so obviously they must be equal to each other. One of the other legs is congruent to the leg of the corresponding leg of the other triangle, and we've got our 90-degree angles. So this is congruent by hypotenuse leg. Let's go ahead. Oh, I put the answers there. All right, so that is it. Today was a lot of information. Today you learned the 5 postulates or conditions that make a pair of triangles congruent. Let's go ahead and write them out. SSS, side, side, side. Side, angle, side, SAS. Angle, angle, side. And angle, side, angle. One side is